Welcome back. In this video, we are going to solve a structural design problem that involves an isolated footing design using working stress method based on eStructural Design Taichi found on the App Store. Design an isolated rectangular footing using working stress method for a 10 inches by 10 inches square column carrying an actual load of 50 kips. Design criteria as follows: strength of concrete 3000 psi, main bars 5/8-inch diameter bar grade 40, soil bearing capacity 2500 psf, approximate dimension ratio of 1:2. The footing carries a column with actual load of 50 kips, an assumed self-weight of 3.25 kips, giving the total load of 53.25 kips. Enumerate input parameters required. F2 for footing name, rectangular shaped, 4 feet deep from natural grade line, 5/8-inch diameter bar grade 40 for main bars, strength of concrete 3000 psi, soil bearing capacity 2500 psf, a 10 inches by 10 inches column sitting on top of footing, and total load of 53.25 kips. Balance section properties as follows: n equals 9.289, k equals 0.385, j equals 0.872. Given the total load of 53.25 kips and soil bearing capacity of 2500 psf, the size of footing is 40 inches by 78 inches. The net soil pressure is 2308 psf. Critical sections for punching shear, beam shears, moment and bond shear. In this example, depth based on beam shear at long direction governs over short direction and punching shear, at which the effective depth is 7.14 inches, round up to 9 inches. Add 3 inches cover for 12 inches total depth. To solve the area of steel at long direction, first get the moment at long direction, which equals to 370,562.22 inch-pounds. The area of steel is 2.36 square inches. Number of bars for 5/8-inch diameter bar is 7.61. Use 8 pieces with spacing at 4 and 7/8 inches on center. The moment at short direction is 140,643.75 inch-pounds, and the area of steel is 0.9 square inch. Use the ACI minimum of 3.51 square inches. Then follow the formula for number of bars to get center strip bars of 8 at 5 3/4 inches on center and outer strip bars of 2 at 8 inches on center. Test for beam shear stress and punching shear stress. By following the computations, we get beam shear stress at long direction is 44.52 psi and 10.69 psi for short direction, both less than 60.25 psi concrete capacity. The punching shear stress is 64.65 psi, less than 109.54 psi concrete capacity. The bond stress at long direction is 177.14 psi and 101.59 psi for short direction, both less than 420.65 psi concrete capacity. The design results for our problem are as follows: Fc prime equals 3000 psi, Fs equals 20,000 psi, footing size at 3 feet 4 inches by 6 feet 6 inches by 1 foot. Long direction bottom bars, grade 40, 8 pieces 5/8-inch diameter bar at 4 and 7/8 inches on center. Short direction top bars at grade 40, center strip bars 40 inches wide, 8 pieces 5/8-inch diameter bar at 5 3/4 inches on center. Outer strip bars 19 inches wide each side, 2 pieces 5/8-inch diameter bar at 8 inches on center each side. Depth of footing from natural grade line 4 feet. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.